Hi there friends, in this tutorial series we're gonna build a space shooter game in Godot 4. We're gonna create a player controller that can move around and shoot lasers. We're gonna create two different types of enemies and an enemy spawner. We will keep track of the score and the high score. We're also gonna create a cool looking scrolling background effect using Godot's parallax background node. There's more that we're gonna cover, so let's get right into it. Okay, create a new project and let's start building this game. First, we're going to create the game scene. This is going to be a 2D scene. We're going to rename this to be the game. And let's save this. And I want my scenes inside a folder called scenes. So I'm going to create a new folder here and save my scene in there. Next up, let's set this scene to be the main scene. To do that, we can just simply run the game and pick the select current option here. This will make the game scene the main scene. And as you can see, we have a blank window here. I want this game to be like a mobile game, so I want the window size to be like this. So let's go into the project settings and fix that. We need to go into the window tab here under display. And we're gonna set the viewport width to be 540 and the height to be 960. I also want the stretch mode to be canvas items. Okay, now if we run the game, we have this mobile-like aspect ratio, which I want. Great. Next up, we're going to create a script here, and I'm going to create some testing functionality to make our lives easier. Okay, so let's first create the script. I want my scripts inside another folder, and this will be the scripts folder. Let's create one here, and let's create the script. And in here, first, I'm going to go into the project settings again, to the input map here, and create a couple of input actions. The first one is going to be quit, and the second one is going to be reset. I will assign the escape key to quit and the R key to reset. We're going to use this inside of the game script. Inside of the process function, we're going to do a check for the quit, and if the quit action is pressed, we simply want to quit the game. So we're going to say get tree quit. Else, if the reset action is pressed, we want to reload the current scene. So this is just so that we can test the game a little bit faster. When I press escape, the game will quit, just like here. So I'm going to press escape, the game quits. And when I press R, the game will basically reload the current scene, which we can't test yet because our scene is empty. So to fix that, let's start creating the player. We need to create a new scene for the player, so let's do that. The root node is going to be a character body 2D. We're going to rename this to be the player and save this scene inside of our scenes folder. In here, I'm going to create a sprite 2D and a collision polygon 2D. For the sprite, we're going to use a texture. So let's go ahead and import our assets. I have some assets here that I prepared. These are from Kenny. There's a link in the description if you want to use the same ones. Let's drag these into the game here. And as you can see, I have audio, fonts, and textures. I'm going to take a look inside of the textures. So this playership1.png is the one that I want to use for the player. So let's drag this into the texture slot. And this looks okay. Let's instance the player inside of the game scene to get an understanding of the size of the player. I'm going to put it at the bottom here and run the game. It looks good, but it's a little too large in my opinion. So let's go back to the player scene and let's set the scale of the sprite to be 0.7 maybe. Let's run the game again. I think this looks nicer. We can change this in the future if we don't like it, but for now, I'm just gonna go with this. And now let's create the collision polygon. I'm gonna click on it, pick the create points tool here, and start creating the shape. We don't need to be perfect. I just want to roughly get the shape of the player here. I usually use a collision shape instead of a polygon, but for this, I'm feeling like creating a little bit fancier, a collision shape that is a little bit fancier. So this will do. And we also want to create a script here. But before we do that, let's click on the character body, and I'm gonna set the motion mode to be floating instead of grounded. So grounded is for platformer-like controls, and floating is for top-down stuff, which is what we have. Now we can create the script. This needs to be inside of the scripts folder. And in here, we're gonna make the player move. So to do that, first, let's create some input actions. We're gonna have 4 different actions: move right, move left, move up, and move down. We're also gonna have a shoot action in the future. So thinking ahead, let's also create this one. Right is going to be the D key, left is going to be the A key, up is going to be W, and down is going to be S. Feel free to use different keys. These are just the keys that I like. Shoot is going to be space for me. Okay, now we can use these input actions. And to make the player move, we're going to use the physics process function. Because the player is a character body, and character body is a physics object in Godot, and when you want to make physics objects move, you need to use physics process instead of just regular process. In here, first we want to get the direction that we want to move in. So we're going to create a direction variable here, and this is going to be a vector2. So let's set this to be a vector2. And for the x and the y, we're going to use a function called input.getAxis. This takes in 2 input actions as strings. The first one is going to be the negative one, in our case, move left. The second one is going to be the positive one, which is move right in this case. We're going to do this again for the y component of the vector2. And this time we're going to use move up and down instead of move left and right. And move up is going to be the negative one because, as you know, in Godot, up is negative in the y-axis. And this line here will basically give us the direction based on which key is being pressed. Okay, I'm now going to explain this in further detail, but first let's print it to see what this looks like. I'm going to run the game. By default, we're getting 0, 0. If I press W, we're going to get 0, -1. If I press S, we get 0, 1. And if I press A, we get -1, 0. If I press D, we get 1, 0. And I can also press them at the same time as well. Okay, so what is going on here? Input.getAxis returns -1 if the first argument is pressed, the -1, in this case move left, and it returns +1 if the second one is pressed. So we're taking advantage of that, and we're creating this vector2 here called direction. Now we can use this direction to set the velocity of the character body. So we're going to say velocity equals direction. And then we also need to do a call to move and slide to make the character body actually move. If you don't call this, this wouldn't work. But of course, direction by itself isn't enough to make the player move at a considerable speed. So we're going to create another variable here called speed. And that's going to be up here. I'm going to set this to be 300. And let's also make this an export variable. So now we're getting the direction and we're multiplying it by speed to set the velocity. And then we're calling move and slide, which will use the velocity and make the player move. Okay, let's give this a shot. Now, as you can see, when I press up, the player goes up and down, left, right. Okay, great. So we don't have to print the direction anymore. This is working. And finally, I want to get a reference to the player from the game script. And to do that, I'm going to go into the player node here, go to the node tab next to the inspector, groups, and in here, I'm going to add the player to a group called player. Now I'm going to go back to the game script, and inside of here, I'm going to create the ready function. I'm I'm also going to create a variable up here called player, and let's set this to be null. And at the start of the game, inside of the ready function here, I'm going to say player equals get_tree, get first node in group, and this will take in a group name, and I'm going to say player here. So this call will basically look at all the nodes in the game and find the ones that have the group player and return the first one. In our case, we're only going to have a single player at any given time, so this will always return the player to us. I usually don't do it this way. I usually just go in the game scene here inside of the script. I usually just create a variable up here like onReadyVar player and just set the player to be like this. But this is also an alternative way to get the player. So this is just a different way of doing the same thing basically. And we could also say assert player isn't null. And this assert will basically create an error if the player is not found basically. And as a final thing, we can go back inside of the game scene here. We can create a marker node here. And I'm gonna rename this to be the spawn position, player spawn position. And I'm gonna put this at the center here. So let's say the X position is 270 and Y is 850. And then we can use this inside of the game script to set the player's position. So even if we had the player somewhere in like stupid in the scene like here, we can automatically set it to be at the spawn position at the start here by first creating a reference to the spawn position. And then after we get the player, we can simply say player.globalPosition equals player spawn position.globalPosition. Now if I run the game, even though the player is up here, it's going to start here. So that's just a cautionary measure to make sure we start the player at the position that we want. Okay, great. So we have the game scene, we did some setup, we also created the player scene, and also we created the player's movement code. If you found this video helpful, please leave a like, comment, and subscribe. If you want to learn more about Godot, I have a course for beginners where I teach everything you need to know in a much slower pace. So if that's interesting to you, check the link in the description. Thank you for watching. I will see you in the next one. Hello friends, in this video, we're going to create the laser scene and shoot it from the player. In the end, it's going to look like this. I can hold down the spacebar and the player is shooting lasers. Let's get started. The laser is going to be a new scene, so let's create one. This is going to be an area 2D because we simply want to detect when a laser touches something else. And then area 2D is the perfect use case for this. I'm going to rename this to be a laser and save this inside of the scenes folder. Next, I'm going to create a sprite 2D here and the collision shape. For the sprite, we're going to use this texture that I have called laserred.png. And by default, it's probably going to be too large, but let's see. I'm actually going to instance a player here so that we can see the laser next to the player. And it doesn't look too bad, but still I want to make it a little smaller. So maybe let's go for 0.8 in the scale. Let's move it down. I think it looks fine. I'm going to get rid of the player. And let's create the collision shape. So this can be either a rectangle or a capsule. Let's go with a capsule. It is a nicer shape, I think. And that looks fine. We also want to create a visible on screen notifier here so that we can delete the laser when it goes outside of the screen. And we can put this at the end here. I'm going to make it a little smaller. We'll put it at the bottom here, a little bit below the end of the laser so that it gets deleted just a little bit after the sprite and the collision shape exits the screen. Okay, next up we need to create the script to create some functionality here. Let's put this inside of the scripts folder and let's create this script. Inside of here, we're not going to do anything complicated. We're going to make this move, so we need to bring physics process back. And in here, we're just going to access the global position because this isn't a character body, this is an area 2D. So we don't have the convenient move and slide function. We need to access the position manually like this. And in this case, we're only interested in the Y component here because we want this to move up. We don't care about the right and the left directions. We're going to add this each frame a speed, which we're going to create, and we're going to multiply this by delta because we're trying to add something each frame, and to make that frame rate independent, we need to multiply it by delta. And this speed is going to be negative because up in Godot is negative, and in this case, the laser will go up. Let's create the export variable speed, and let's set this to be, so the player moves at 300, so this should at least be 600, I think, and even this might not be enough. We'll see. Okay, so this should be enough to make it go up. So before we start spawning this from the player, let's go to the game scene and let's instance a laser here, and let's put it at the bottom, and let's run the game. Yes, we can see that it is going up. That is all good. Now we can think about instancing the laser scene from the player, or first we can use the visible on-screen notifier that we created here. What we're going to do is we're going to click on it, take a look at its signals. It has the screen exited signal, which is emitted when this visibility notifier exits the screen. We're going to connect this signal to the laser script. So when the laser exits the screen, we don't need it anymore, so we can just call QFree. And this will take care of the lasers that we shoot and miss the target. Okay, now we can go to the player scene. And in here, we're gonna spawn the laser when the shoot input action is pressed. I'm gonna create a marker 2D here I'm gonna call this muzzle, and this is gonna represent the point that the player shoots the laser from. We're gonna use the global position of this, basically. And inside of the script, I'm gonna create a variable to hold the laser scene, and we're gonna preload the packed scene here, laser.tscn. We're gonna create a function called shoot, and in this function, we're gonna shoot the laser. In fact, we're actually not gonna do that. We're gonna create a signal up here called laser shot. And we're just going to emit this signal here. Because if we instance the laser here inside of the player and add it as a child of the player, then the position of the laser will be affected by the player, and we don't want that. What we're going to do is we're going to create this signal emitted when the shoot action is pressed, and then in the game script, we're going to connect this signal and instance the laser there and add it as a child of the game scene. Okay, so I'm gonna bring the process function here because this isn't a physics thing that we're doing, so we don't need to use physics process. We can just do this inside of regular process. And in here, we're gonna do a check for is action just pressed shoot. So when the shoot action is pressed, in this case the spacebar, we're just gonna call the shoot function that we created. And in here, let's do a few things. Actually, let's see. We can either instance the laser here and send the instance with the signal, or we can just send the preloaded packed scene with the signal, and then we can instance it inside of the game script. Let's do it that way. So this signal will actually take the laser scene and the location that we want to put this laser on. And in shoot, we can simply say laser shot, which is the signal, dot emit, and then we need to give the arguments. The first one is going to be the laser scene that we preloaded here. The second one is going to be the position. In this case, we're going to give the position of the muzzle. So let's quickly create a reference to it up here. And down here, we can just say muzzle.global position. And the shoot function is basically complete. We're basically emitting the signal and we're passing the laser scene and the position of the muzzle, the global position of the muzzle. Now we need to go to the game scene, and we can either connect the signal from the inspector or we can just do it inside of our script here, because we already have a nice reference to the player here, so why not connect the signal in here as well. I'm going to say player.lasershot.connect, and we're going to connect this to on player laser shot. Of course, we need to create this function, which I'm going to do down here, and this will take in the laser scene and the location. So we are being passed these. Remember, we gave it to the signal here, and now we're getting it back. And in here, we can simply create a new instance of the laser by saying laser scene.instantiate. I hope I spelled that right. Then we need to use the global position and set that to the location that we got passed. And finally, we can add this laser as a child. And instead of adding it as a child of the game, I'm going to create a new node here. This is going to be a node 2D called laser container, so that it is all nice and tidy inside of our main game scene. Let's create a reference to this. And we can simply say laser container.addChild laser. Let's try this and see. When I click space, a new laser is instanced and everything seems to be working. Let's take a look at the remote tab. This will show us the running game. And inside of the running game, we shouldn't have any lasers. And we don't. Good. That means the lasers that went outside of the screen got deleted, and we can see that in action here. If I start shooting, you can see that we have some lasers, but they immediately disappear because they're being deleted. Great, so a small little recap inside of the player. Well, first we created the laser scene, obviously, and area 2D. We have the visible on screen notifier to delete it when it goes out. And in the physics process, we're simply making it go up in the y-axis. The speed seems to be fine as well at 600. So this is the laser scene. Then we went to the player scene, to the player script. We created the muzzle first. And then we have the laser scene here as a preload variable. This can also be in the game scene, the game script I mean, but this is the way we decided to do it. We have a signal called laser shot, which takes in a scene and a location, which is a position 2D. We're checking for the shoot action that we created in the previous lecture, and when the shoot action is pressed, we're calling this shoot function, which simply emits the laser shot signal here and passes in the laser scene and the position of the muzzle. Finally, inside of the game script, we connected the player's laser shots signal to a function that we created here, and in here we're simply instancing the laser scene that we were passed. We're setting the position to the position that we were passed in, and finally we're adding it as a child of the laser container. Everything is good. Finally, I want to make it so that we can hold down the spacebar and keep shooting, because with this setup, we need to keep clicking, keep pressing the spacebar to shoot, and I don't like that. I like to hold it down, hold the spacebar down, and keep shooting. So that's going to be very simple to do actually. We just need to create a variable here called shoot cooldown. I'm going to say CD for short, and we're going to set this to be false at first. So this is going to be a Boolean. When we press the shoot action, we're simply going to check if shoot cooldown is false, which I'm going to say not shoot cooldown, which means the shoot cooldown is false. We're going to shoot. But before that, we're going to set the shoot cooldown to be true. And after we shoot, we can just use the await keyword, create a timer here with getRecreateTimer. And let's set the timer to be like 0.25. And we need to wait for its timeout signal. So this will basically turn this function into a coroutine. What this means is, and after this, I'm going to set the shoot cooldown to be false. What this means is when we press the shoot action, we're going to set the shoot CD to be true, shoot, and then we're gonna wait for 0.25 seconds, and then we're gonna set the shoot cooldown to be false again. So until this await is done, we're not gonna get into this if statement because the shoot cooldown will be true. We also need to change the is action just pressed to is action pressed, because just pressed only checks the action once when you press it, but is action pressed will keep checking it as long as you have it pressed. Okay, let's try this out. I'm gonna hold the spacebar down, and as you can see, I'm shooting, and when I let it go, I stop shooting. And you can play with this 0.25 here to achieve different effects. For example, if we set this to be 0.1, we're gonna really fire rapidly, as you can see. We can actually make this a variable as well. We can say rate of fire here, which is going to be an export variable as well up here. And we're gonna set this to be 0.25. Okay, so this is gonna be it for this lecture. Now we have a laser scene, and we're shooting that laser scene from the player, and everything is looking good. If this video was helpful, please leave a like, comment, and subscribe. If you want to learn Godot, I have a course where I teach this stuff in a much more slower pace for beginners, so be sure to check that out. There's a link in the description. Again, thank you for watching. I will see you in the next one. Welcome back, friends. In this video, we're gonna create the enemy scene. In the end, we're gonna have this enemy that goes down, and we can shoot it with our laser. Let's get started. Okay, so the enemy scene is going to be very similar to the laser scene. So let's create a new scene first, and we're gonna make this an area 2D, just like the laser. But this one, we're gonna rename it to be the enemy. Let's save it inside of our scenes folder. And in here, we're gonna have a sprite 2D and a collision shape 2D. For the player, we use the collision polygon. This one, I'm gonna go with the simpler option, which is a shape, but feel free to create a polygon for this as well. For the sprite, we're gonna use the spaceship 1 PNG that we have. I have a bunch of these. I'm just gonna use the first one. Let's click on the inspector first, and let's drag this here. It is a bit too large, probably just like the player. Let's go into the game scene and let's instance one of these. And next to the player, it does look a bit too large. So inside of the enemy scene, let's set the scale to be 0.65, let's say. And let's take a look at it. And that looks fine. Okay. So the enemy, just like the laser, needs a visible on-screen notifier, but it is going to be on the opposite side because this one will be going down instead of going up. I'm gonna put this at the back, just like the laser, so that we have a little bit of lag between the time this goes outside of the screen and the thing gets deleted. Let's also not forget to create a shape here. I'm just gonna create a circle. This looks fine. And we, of course, need to create a script here. Let's put this inside of the scripts folder. Let's create it. And in here, we're going to make this go down. So let's create the physics process function. We need to access the Y property of the global position, just like we did for the laser. In fact, we can copy this and use this, and it will work. But in this case, we don't want to say negative speed because we are going in the opposite direction. Let's create the export variable speed here as well. And let's set this to be like 150. So this is going to be slower than the player. Okay, with this much, the ship should be going down if we run the game. And as you can see, it is, but we can't really shoot it. So let's work on that. Okay, we need to start creating the interaction between the laser and the enemy and the player, because we also want the player to die when an enemy touches the player. I'm gonna go into the project settings, scroll down and go into the 2D physics section here underneath layer names. In here, we're gonna create some physics layers. The first one is going to be the player, second one, the enemy, and the third one is going to be the laser. And we're gonna go into the each scene, starting with the player, click on the character body and set the collision layer to be the first one, which it is by default. And this will look for, not for the player mask, but for the enemy. So because the enemy won't be shooting lasers, we don't need to check for laser, but if in the future we decided to check for the laser as well, we'll also check this one. Okay, so that's the player scene. Let's go into the laser, area 2D here, into the collision options. This will be on the third layer, and the laser will look for the enemy. And finally, let's go to the enemy collision here, and this will be on layer 2, which is the enemy layer, and this will check for the player and also the laser. Okay, so we have the physics layers configured. The second step is going to be detecting the collision between the laser and the enemy. And because we made these area 2Ds, that's going to be extremely simple. We just need to decide, do we want to check that in the laser script or the enemy script? So I'm gonna do this in the laser script to check for the laser hitting the enemy. And then we'll do the enemy hitting the player inside of the enemy scene, enemy script. So inside of laser here, we're gonna go and check the signals, and we have an area entered signal here. We can simply connect this to the laser script, and we know that the only area the laser is going to interact with will be the enemy. But just for some extra checking, we can go into the enemy script first and add a class name here and set this to be enemy with a capital E. This lets us go into here and say if area is enemy, and we of course need to save it first inside of the enemy script. So the class name, setting a class name like this lets us use this name enemy to check if this area is an enemy or not. So in here, inside of this if statement, we know that the laser hit an enemy. So what we can do is we can delete the laser with QFree, and we can also delete the enemy, which is this area here. But instead of freeing it directly, I'm just gonna call the die function of the enemy, which we didn't create yet. So let's go into the enemy script and create a function called die. And in here, we can simply say QFree. For now, in the future, we're probably gonna have a signal here that we're gonna emit to the game script, but for now, we can just call QFree. Okay, so now when the laser touches an enemy, the enemy and the laser both should be freed. So let's try this. I'm gonna shoot the enemy and they both get deleted. That's good, that's what we want. And now finally, we also want the player to be deleted when the enemy touches a player. That is also going to be simple to do. We just need to go into the enemy scene here, and because enemy is an area 2D, it has all these useful signals. In this case, we're going to use the body entered signal because the player is a character body. So the body entered signal is the correct one in this case. Let's connect it to the enemy script. And in here, we can do the same thing we did for the enemy. We can go into the player script, create a class name attribute here, so that we can check for it inside of an if statement here. We can say if this body, which is the argument here, the body that the enemy interacted with, if this is the player, we can call a die function on the player, which we're going to create. And we can also call the die function of the enemy. Let's save it. And of course, we need to create that die function inside of the player script here. And for now, we can just call QFree. We will also most likely have a signal here in the future, but for now, this will do. Are we still getting an error here? No, okay, great. So with this, now we should be able to touch the enemy with the player and they both get deleted, which is exactly what we want. Okay, so the next step is going to be spawning the player, but we're going to do that in the next video probably. But let's do a small recap and then we can end this video. We created the enemy scene, which is just like the laser. It's an area 2D. It has a script And in the script, we're making it go down instead of going up. And then we created the interaction between the player, laser, and the enemy by creating some physics layers and using the signals of the area to the enemy and the laser. So inside of the laser script, we're deleting the enemy and the laser when they touch. And inside of the enemy script, we're deleting the player and the enemy when they touch. Finally, I think we forgot to use the visible on screen notifier here, so we can quickly connect the screen exited signal. And inside of here, we just need to free the enemy. And this should result in the same behavior as the laser. When the enemy goes outside of the screen, it should get deleted. Okay, great. Like I said, next step is going to be spawning the enemy so that we don't have to add it manually to the game scene like this. We can also get rid of this laser here. And I'll keep the enemy until we create the spawner. Okay, great. Thank you for watching. If you liked it, please leave a like, comment, and subscribe. If you want to learn Godot, I have a course where I teach the basics of Godot at a much slower pace for beginners. If you're interested, check the link in the description. Again, thank you for watching. I will see you in the next one. Welcome back, friends. In this video, we're going to create a new enemy type and implement the enemy spawning functionality. Let's get started. We created this enemy scene, and this scene has all the basic functionality that we want. Now I want to create a new enemy type. And I know that the same basic functionality is needed for this new type. I could go ahead and create a new scene and recreate everything that we have here and add the extra functionality that I want. But instead of doing that, we can just use an inherited scene. Let me show you what that looks like. To create one, we need to go to the scene menu here and click on New Inherited Scene. Next, we need to pick the scene that we want to inherit from. In this case, it's going to be the enemy scene. This will create a new inherited scene for us, and it will look exactly like the enemy scene. In fact, at the beginning, it will be identical. I'm going to rename this scene to be the diver enemy and save this inside of the scenes folder. When you create an inherited scene, you will get all the functionality from the scene that you inherited from. So this scene, even though it's a different scene than the enemy scene, has all the nodes that the enemy scene has, and it also has the script, the enemy script, attached to it. The nodes that we inherited are written in yellow, as you can see, and I can't really change these from here. For example, I can't delete an inherited node. As you can see, it is telling me can't operate on nodes this current scene inherits from. So we can't really delete them and change their position, but we can change their properties in the inspector. So for example, for this enemy, I can use a different texture. Let's use this spaceship 4. And the sprite is a little bit larger, so I'm going to make this 0.5 for the scale. As you can see, we can change the properties from the inspector, but we can't really mess with the nodes in the scene tab. But that is, like I said, only for the inherited nodes. We could create our own nodes here if we wanted to. So for example, I could create a new node here, and with this one, I can mess with it, delete it. It's only the inherited ones that I can't really change. And also, if you make a change in the parent scene, in this case, the enemy. So for example, in here, if we change the name of the sprite here to sprite from sprite 2D and save, as you can see, that change is reflected in the inherited scene, the diver enemy. Okay, great. So because we did that, I think the sprite's texture property got reset because we made a change to it from the parent scene. So you need to watch out for things like that. So let's do that again and give this guy the correct texture and put the scale back. Let's save this. So yeah, enough about explaining the inherited scenes. And let me talk about what I'm trying to do here. So this is a new enemy type that we're going to have. This one will be significantly faster. That is why I called it the diver enemy. I'm going to go to the root node here and set the speed of this to be 400 instead of the 150 of the regular enemy. So if you go back to the game scene and instance one of these here, you will see that it is significantly faster. So that is just a new type of enemy that we're going to have. And because I now showed you how to create a new enemy type, you're free to create 10 different types of enemies here. So by creating an inherited scene just like this, we have a new type that has all the same functionality as the normal enemy, and it only took us like 30 seconds to make this. So in a case like this is okay to use, but this can get messy if you try to make changes to the base scene. And down the line, like I said, this can get messy. So I don't really recommend using inherited scenes too much, but in certain cases they're helpful. You can also create a script here as well and inherit from the enemy script if you want to create more, functionality inside of a script, but only for the diver enemy. You can also do that. We're not going to do that in this case. But yeah, now that we have a different enemy type, we're going to move on to spawning this enemy and the regular enemy inside of the game scene. Okay, so let's go back to the game scene, and in here we want to spawn enemies from the top in random locations. We're not going to need these enemies anymore, so I'm going to delete these. And in here I'm going to create a new node 2D, and this one is going to be the enemy container. So just like we did for the laser, we're going to have a container node to have the enemies in so that the game scene is nice and tidy. Inside of the script, I first want to create an export variable here. Up here, let's create a new variable. And this is going to be the enemy scenes. And this is going to be an array. So I'm gonna give this a type, and this is going to be an array of packed scenes. And it's gonna be an empty array by default. And if we take a look at the root node, this is what that looks like. In here, we're going to set the size to be 2 because we only have 2 different enemies. If you have more, be sure to set this to the amount of enemy scenes that you have. And then we're going to go into our file system, scenes, and then we're going to drag our enemies here. So we essentially have the enemy scenes, the packed scenes inside of this array. And now I'm going to create a timer node inside of the game scene. So let's create a timer here. We're going to call this the enemy spawn timer. I'm going to set this to be auto start, and the wait time is going to be 1. I'm going to put this at the top, and let's create a reference to this. Even though we don't really need it, now that I think about it, let's see. We might not need this, but okay. I'm going to connect the signal. Yeah, I guess I could use this to connect the signal, or I can just do it from the inspector here. Both ways are okay. So let's connect the signal, the timeout signal. And whenever this timer times out, we want to spawn a new enemy. We have the packed scenes inside of an array here, so we want to pick a random packed scene, instance it, and add it as a child. And we're gonna add it as a child of the enemy container. Let's create a reference to that as well. And down here we can create a new enemy instance. I'm gonna call that E. This is going to be the enemy scenes dot pick random to pick a random packed scene. And then we're gonna call the instantiate function. I think I spelled that wrong. Let's see, instantiate. Okay, so this will create a new enemy instance for us. And then we want to, well, at the end, we of course want to add this as a child of the enemy container. But before we do that, let's give this a position. For starters, I'm gonna set the position to be, let's see, what was our window width? 540, so let's say 270 by 0. In fact, let's say 50 so that we can see it actually. So this will create a new instance, set its position, and add it as a child of this scene. Okay, let's run the game and see if this works. And you can see that we're spawning an enemy every time the timer times out, and it is a random one between the regular enemy and the diver enemy scene. Great, now the next step is spawning these at the top at a random position and a little bit above the scene so that we don't see it spawning like these guys here. Okay. That is going to be this line here. So instead of giving it a constant value like 270 here, we want to pick a random X position. So the X is going to be random, but the Y is going to be the same. So the X is going to be random F range. This will give us a random floating point value from a range that we're going to determine. And the range is going to be from, well, the window width is from 0 to 540, right? But we don't want to use the full width. We want to have a little bit of a margin. So I'm going to say 50 to 500. And we can change this if some enemies are outside of the screen or something like that. And the Y is going to be, well, let's leave it at 50 at first. Now, as you can see, we're spawning the enemies at a random X. And the only thing we need to do now is taking the Y and, spawning it above the screen. And to do that, we can simply say -50 instead of 50. This way, we can't really see the enemy when it spawns. And that's exactly what we want. Okay, so that is going to be it for spawning the enemy. There's also one thing I want to do for the different enemy types actually that I forgot to do, and that is giving them different hit points. So currently, both the enemy and the diver enemy has a single hit point. They both die with a single laser. But that kind of defeats the purpose of having different enemy types. That just makes the diver enemy much more stronger than the regular enemy. So what I want to do is I want the regular enemy to have 2 hit points so that it's a little bit more difficult to kill, but in turn it is slower. And I want the diver enemy to have a single hit point so that it is more easy to kill, but it's faster, so it kind of balances it out. To do that, we're going to take a look at the enemy script here. We're going to create a new export variable called HP, and I'm going to set this to be 1 by default. And for the diver enemy, we're going to set this to be 2 for the diver enemy, it's going to be 1. For the normal enemy, we're going to set this to be 2. Okay. And in here, inside of the script, when the laser touches an enemy, we're not going to call die. We're going to call a function called take damage. And then inside of the enemy script, we need to create this new function called take damage. And this will actually take in a variable called amount. So when this function is called, what we're going to do is we're going to say HP minus equals amount. So we're going to subtract whatever amount we were passed from the hit points of the enemy. And then we're going to do a check. So if HP is less than or equal to 0, this means the enemy just died, so we can call die. Otherwise, we're not going to die. So now from the laser script, we need to give this a damage. I'm going to just say 1. We can also turn this into a variable here, so some lasers can have more damage. So instead of saying 1, we can say damage here. And if you want to create different types of lasers, you can give them different amount of power from here. Okay, great. Now when a laser touches an enemy, it applies damage. And if the enemy's HP goes below 0 or equal to 0, it dies. So now if we run the game, we should be able to kill the diver enemies with 1 hit. Oh, we can't. Why is that? Well, the regular enemies seem to be fine, but for some reason, diver enemies also have 2 hit points. Let's see. Oh yeah, they have 2 hit points here. Why is that? Did I? No, I did set this to be 1. Oh, it's probably because they're inherited. Yeah, see? Okay, that's funny. Because they inherit from the enemy, even though enemy has this, even though the enemy script has it 1 as default, because we changed it in the inspector and because the diver enemy inherits from the enemy scene, it also got the change as its own default value. So it's kind of complicated there, but we just need to set it to be 1 in the diver enemies inspector variables here. Now we should be able to kill the diver enemies with a single laser. Yep. And the normal enemies should be 2 laser hits. Yep, that seems okay. Okay, so that's gonna be it for this lecture. In this one, we first created a new enemy type using inherited scenes. We gave it a different speed and a different sprite texture to, differentiate it from the regular enemy. We also created this HP variable for the enemies, and the diver enemy has 1 HP and the regular enemy has 2. So that was the different enemy type. We also did the enemy spawning code inside of the game scene here. We created a timer node and connected its signal in here inside of the game script. And whenever the timer times out, we're creating a new instance of a random enemy that we pick. We're giving it a random position and we're adding it as a child of the game scene. And that's going to be it for this lecture. If you found it helpful, please leave a like, comment, and subscribe. If you want to learn Godot, I have a course where I teach the basics of Godot at a much more slower pace for beginners. If that is interesting to you, check the link in the description. Again, thank you very much, and I will see you in the next one. Welcome back, friends. In this video, we're going to create the scoring system and the UI to display that score. In the end, it's going to look like this. I have a label that keeps track of the score, and whenever I kill an enemy, the label is updated. Let's get started. Okay, so before we create the scoring system, I want to clamp the player's movement. Currently, if I want to, I can just leave the game area, and that shouldn't be allowed. So let's go into the player script, and in here we want to write some code inside of the physics process. So after we call move and slide, let's make sure that the global position of the player isn't outside of the game area. So we know that the game area in the game scene here starts from 0, 0, and it ends at the window size basically. Because we don't have a camera here and the game's left edge is at 0, 0, we know that the right edge on the x-axis is 540 and on the y-axis it is going to be, what did we set it to? 960. So this bottom right edge here is 540 to 960 and the top left edge is at 0, 0. So we want to make sure that the player's global position is inside of this rectangle here. Okay, so inside of the script, we are going to use the, let's say, global position equals, so global position is a vector 2. And a vector 2 has a built-in function called clamp. You can call it by simply doing .clamp on any vector 2, and this will take in 2 values. The first one is the minimum value. In this case, it is going to be vector2.0. So this is simply a vector 2 that has 0 in x and 0 in y. And the next argument is going to be the maximum value. And this one is going to be we're going to call get viewport rect dot size. And this will return a vector 2 that is the size of the window, the viewport rect essentially. In our case, that is going to be a vector 2 with the x value of 540 and y value of 960. So this clamp will return a vector 2 that is above 0, 0 and below the screen size. And this will make sure that we stay inside of the game area. So let's run the game and see what this looks like. So I'm trying to go out right, it doesn't work. Can I go down? It doesn't work. Can I go left? Make sure I don't get killed. It doesn't work. It doesn't work, but like half the player can go out. I think that's fine. I don't want the player to stop like here. I don't think that looks natural. That feels natural. Oops, we died. Okay. Let's try the up as well. Hopefully before... Oh, I died again, but I did try to go out for a split second there and it didn't work. So don't worry, this works. Okay, now we can move on and create the scoring system. So that is going to be inside of the game script. We're going to create a new variable here called score. This is going to be an integer, and we're going to set this to be 0 by default. We want to increase this score each time the player kills an enemy. But currently, we don't know when an enemy gets shot. Inside of the game script, at least. Inside of the laser script, we know that the enemy is killed in this function. And we know that the enemy's take damage function is called here. So actually, it isn't in this function. It's in this function here that we call die. We basically need to let the game script know when the hit points of the enemy goes below 0. To do that, we're going to create a signal here called killed. And we're going to emit this signal inside of the, let's see, we could do it inside of the die function here, or we can do it inside of take damage. Let's do it here. So before we call die, we're going to say killed.emit. Now we can go back to the game script, and inside of the timeout signal callback here, before we add the enemy as a child, we can connect the killed signal of the enemy to a function called onEnemyKilled. Let's create this function. Okay. Now we have access to the exact point in time when enemy is killed. So in here, we simply want to add to the score. I'm going to add 100 to the score each time an enemy is killed. Feel free to use a different value here. It is completely arbitrary at this point. And then we can print the score for now just to see that this is working. So I'm going to start the game and shoot some enemies. And as you can see, each time I kill an enemy, our score is increased by 100. One cool thing we could do is inside of the enemy, we could create an export variable here called score, for example, or points, let's say, and let's set this to be 100. So for the default enemy, the points are 100, but for the diver enemy, we could do this. We could give it a higher value like 200. And when we emit the signal killed, we can actually send these points. And from the game script, we can also receive them here. And instead of adding 100, we can just add points. Now, when we kill the diver enemy, let's see, we should get 200 points. And if we kill a normal enemy, we get 100. As you can see, it is working. Great. So that is the scoring system in a nutshell. Now we just need to create the UI to display it to the player. Okay, to do that, we're going to create some new nodes and a new scene here. So inside of the game scene, let's create a canvas layer. Because we want the UI to be on a different layer, a different drawing layer, I'm going to call this the UI layer. And I'm going to put this at the top. It doesn't really matter because if you take a look at the layer here, it is at layer 1. By default, everything in Godot is displayed at layer 0. So because the UI layer is at layer 1, everything that is a child of the UI layer will be displayed above everything else. And in here, we're going to create the HUD. So let's create a new node here. And this is going to be a control. Let's rename this to be the HUD. And I'm going to turn this into a scene. Right click, save branch as scene. And we're going to save this inside of the scenes folder. Let's go to the scene. So this is going to be our HUD. I'm going to make this full rect. And in here, we're not going to have much. We're only going to have a label here. So let's create a label node. This will display the score. So I'm going to rename it to be the score. I want this to be the top wide anchor preset here. And in here, we're going to give some text. Let's also set the alignment to be in the center. And I'm going to say score is 9999. I'm going to create some label settings as well here so that we can change the font size. Let's make it bigger, like 64 maybe. Maybe 48. We can also use a different font. I have one here inside of my assets. I'm going to use this one. That looks nice. And now we want to create a script here for the HUD. So let's do that as well. Make sure to put it inside of the scripts folder. And in here, we want to create a reference to the score label. And I'm going to create a set function here. And whenever someone tries to set this score variable here, I'm going to change the text property of the label instead of changing the label. I'm going to say score.text equals score plus the string version of the value. So instead of setting the variable, whenever someone tries to set this variable, we're going to change the text property of the label, and you'll see why this will be, easy to use for us. Okay, now we can go back to the game script. We can create a reference here to the HUD. And now we can use the HUD's score property whenever we want to change the label's text. So in the ready, I could say HUD.score equals 0, and if I run the game, this would set the score to be 0. I'm gonna do a similar thing here inside of the game script as well. I'm gonna create a setter for the score, and whenever someone tries to set the score variable, we first will use the value that was passed to set the score, and then we're gonna set the HUD's score variable to this score as well. With this setup, we don't even need to call, set the HUD score variable anymore. We can just set our score and it will automatically set the HUD as well. Now I can say at the start score is 0, and whenever an enemy is killed, we're adding to the score, so this will automatically work now. Let's take a look at this. So at the start, score is 0, and if I kill an enemy, as you can see, the score label is being updated. And like I said, this is because whenever score is set, we're setting the HUD as well. Okay, so great. This is going to be it for this lecture. Feel free to play around with the HUD here. If you didn't like the font size, for example, feel free to experiment there. I'm not going to waste time with that. In this one, we created the scoring system and the UI to display the score. We also did the player's clamp code to make sure the player stays inside of the game area. Thank you for watching. If you found the video helpful, please leave a like, comment, and subscribe. If you want to learn more about Godot, if you're a beginner, I have a course where I teach the basics at a much more slower pace. So if that's interesting to you, check the link in the description. Thank you very much for watching, and I will see you in the next one. Hello friends, in this video we're going to create the game over screen and the Highscore functionality. In the end, we're going to have this game over menu that we show after the player dies, and it has the current score and the Highscore. Let's get started. Currently, when the player dies, nothing really happens. The player is deleted, but other than that, the game just keeps going. We want to display a game over screen here, so let's start creating that. That's going to be a new scene that we're going to have inside of our UI layer. So let's create a new scene. This is going to be a user interface scene, so we're going to have a control node here as the root node. I'm going to rename this to be the game over screen. And let's save this inside of our scenes folder. We're going to set this to be full rect. And in here, we're going to create some user interface nodes. Firstly, I want to create a color rect here. And I'm going to make this full rect as well. And set the color to be black. I'm going to set the alpha to be like 125. And I'm going to go back to the game scene and instance a game over screen here inside of my UI layer. So when the game ends, I want the game over screen to pop up and I want everything else to be kind of tinted black. So that's why I created this semi-transparent color rect here. Okay, next up, I want to create a panel here. This is going to be in the center. So let's set the anchor preset to be center. I'm going to make this larger, about this size. And I want to go into the theme overrides here to styles and create a new style box flat. This will let me pick a custom color for my panel, and I'm gonna make it a bluish color, more like a cyan, I guess. Let's increase the saturation, and that looks fine. I'm also gonna give it a corner radius of 25 pixels for each corner so that the corners are nice and rounded like this. And that's gonna be it for my design for the panel. Feel free to, mess with this more. And inside of this panel, we're gonna create a couple of labels and a button. So firstly, let's create the game over label. We're gonna rename this to be game over. And I'm gonna put this at the center top. Let's create some label settings here. Let's give it some text, game over. We're gonna make the font size much bigger, but first let's set the font to be the Kenny Future font. And then let's start increasing the size. 45 seems to be good. Maybe 46. Okay, 46 seems good. Let's move it down a little. Okay. Next up, I'm just going to duplicate this label. And this one is going to be the score label. Let's see. Let's put the high score first. So this is going to be the high score. I'm going to anchor this to the center and move it up above a little. So the text is going to be high score equals 9999. We of course want the label settings to be different, so I'm gonna right click on it and make it unique because we duplicated this. If you don't do that, when you make a change to the label settings, it's also gonna affect the game over's label settings. I'm gonna make the font size smaller here, maybe 32. 36. Let's try 35. 34. Okay, that looks fine. Let's duplicate this as well, and this one is going to be the score. And I'm gonna put this a little bit below the high score. And instead of saying high score, this will be just score. And I'm gonna align this to the center. I'm also gonna align the high score to the center as well. Okay, I'm actually gonna maybe move these slightly up like that, and I'm gonna make the panel smaller. I feel like it's a bit too large, but not like that. Like that maybe. And then of course I should move these down a little. Okay. Finally, we want to create a button here, so let's do that. Let's create a button, and this is going to be the restart button. We're gonna put this at the center as well and move it down. And this is gonna say retry. Let's say retry. That's a better word than restart. And we need to go into the theme overrides here and give this a bigger font size and a font. So the font size is going to be 32, maybe 35. And let's also make the button bigger as well, like this. Okay, that looks good. Okay, what else? I still want to make the panel smaller. So maybe like this, and put this in the center again, and move it up a little bit more. And let's also put the high score and the score down like that. Let's see. I'm gonna make the game over label bigger, 48, let's say, maybe 52. And let's make the panel wider. Okay, I'm getting a little OCD here, and I'm gonna stop. Okay, that looks fine. So this will be the game over screen. We're also gonna create a script here. Put this in the scripts folder. Inside of here, we basically want to create two different functions to set the high score and the score. We also want to connect the restart button's pressed signal. So let's start by doing that. And so this signal will be emitted each time the button is pressed. And when that button is pressed, we're gonna reload the current scene. Simple. And like I said, we also want to create some functions to set the high score and the score. So first I'm gonna create some references here. Actually, I'm not gonna create references. I'm just gonna create the functions. Set score, let's say. This will access the score node, just like this, and set the text to be score equals string value. And for the high score, we're going to do the same thing, but the function name is going to be different. And we're going to access the high score instead of the score there. Okay, so this will be the game over script. Now we simply want to use this inside of the game scene. So in here, if we play the game now, we will immediately see the game over screen, which is not what we want. So let's set this game over screen to be invisible when the game starts. And when the player dies, we will show it. Inside of the script, when the player dies, do we have a signal for that? Doesn't seem like it. Okay, so we should go into the player script here and create a new signal called killed, or maybe died. Let's say killed, it's fine. And inside of here, let's see, we have a die function, good. So here we can just say killed.emit. Now we can go back to the game script, and here we're connecting the player's signals, good. We'll also connect killed here to onPlayer killed. Let's create this function down here. So when the player is killed, we can basically just set the visible property of the game over screen to be true. So first, let's create a reference to it. I'm just going to shorten this and say GOS for game over screen. And down here, when the player dies, we can simply say GOS.visible equals true. And let's also do an await here and create a timer for 1.5 seconds and wait for its timeout signal. This is just so that we don't show the game over screen immediately after the player dies. We're going to have a 1.5 second delay to create a better game feel. Okay, let's see what this looks like. So I'm going to go ahead and touch an enemy. And okay, we got an error here. What is going on? Okay, I misspelled create. Let's try this again. Let's see. Okay, let's die. Wait. And the game over screen pops up. Great. The next step is setting the score here. And then the next step will be setting the high score. Okay, to set the score, it's not going to be difficult actually. So before we set visible to true, in fact, before we start waiting, we can say GOS.setScore, and we can just set this to be our current score. This way, let me shoot some enemies first before dying. So we have a score of 700. Let's die. And now the score is correct. The next step is going to be setting the high score. The high score is going to be a variable inside of our game script, just like the score variable we have. So underneath this one, let's create a new variable called high score. And each time we kill an enemy, we need to do a check. So if the score is greater than the high score, we're going to set the high score to be the score. So let's say the high score was 100. Each time we kill an enemy, we will check our current score. And if it is greater than 100 in that case, the high score is going to be the current score that we have in this run of the game. And we can stop printing the score here. Okay, so this is okay, but the problem is each time we reload the scene, the high score will be resetted. And even if we, fix that inside of the game, let's say we're keeping the high score in a separate, global script, an autoload script, let's say, a singleton, we would still run into the same problem when we quit the game and launch it again. So we need to save the high score to our file system, to the disk, and load it each time we start the game. To do that, we're going to use the file access API of Godot. So underneath the ready function here, let's create a new function called save game. And in here, we're going to try to open up a file with the file access API, like I said, using the open function. In here, we need to give it a path, and that's going to be user save.data. And then we need to give it a file access mode, and that's going to be write. So this file path here is a special path Godot uses to save data on a user's machine. So this is the path, this user path is the one that you should use whenever you want to save something on the user's computer. Res is the resources folder. It is the file system that we have here. And this one is for the files that you have inside of your project. You shouldn't use this file path to save something on the user's machine. You should use the user path here. And in here, inside of user, we're going to create a file called save.data. File access.open will try to open this file, and because we're trying to open it with write, it will actually delete whatever it's in there and open up a new file. And we can store this file handle in a variable here called save file. And then we're going to say save file store 32 Highscore. And this function call will store our Highscore inside of this save file that we just opened up. So because the only thing that we want to store in our game is the Highscore, we can just, delete whatever was inside of the save file and store this Highscore value that we have. So this is for saving it, but we also want to load it at the start of the game. And to do that, we're going to do a similar thing. In here, we're going to say save file. We're going to access the file access API again, open the same path, save.data. But this time, we're going to use a different mode. This time, we're going to try to read it, because read won't delete the file. Write will basically destroy whatever you have here and create a blank new file for you. In fact, we can probably read these inside of the documentation here. Yeah. So read opens the file for read operations. Write opens the file for write operations. It is created if it doesn't exist, which is exactly what we want, because at the first time you play the game, the file won't be there. So write will create it for us, and it will truncate it like you see here. But anyways, let's go back to the game script. And in here, inside of ready, we're trying to open the save data file. And we can check if this worked or not by saying if save file isn't null. So if this works, the save file won't be null. So inside of the if statement, we can just get the Highscore by calling get32 this time instead of store32. So the Highscore that we stored here, we can get it back with get32. And if this file is null, that means we don't have a save file. So this is probably the first time the user is playing the game. Then we can just do a save here. It's not really necessary, but we can just do it to create the file. And then we can set the Highscore to be 0. In fact, we should probably set the Highscore first and then save that. And that will create the file for us. Okay, the last thing we need to do here is when the player dies, we of course want to set the game over screens, set Highscore function to the Highscore. And we also want to save the game. Okay, let's see if this works. I'm gonna run the game. So the first time, we should have the save file now, but we should have a Highscore of 0. So when I die, we have a Highscore of 0. That's good. I'm gonna retry and get a Highscore this time of 300. Let's die again. And this time Highscore is 300, but let's see if this stays when I retry. So I'm gonna retry and die again. And as you can see, Highscore is still there. That's good. Let's try beating this Highscore. Let's try getting a higher Highscore. Let's die. This time, as you can see, Highscore is correct again. And let's die one more time to see it there. Okay, that also works. Finally, I'm gonna quit the game and launch it again. And let's see if we still keep the Highscore. As you can see, we do. The Highscore is still there. Great. So that is how to create the Highscore in our game. And that's going to be it for this lecture. In this one, we created the game over screen and we implemented the logic inside of the game scene to show it when the player dies. We also created the high score. Thank you for watching. If you found this video helpful, please leave a like, comment, and subscribe. If you want to learn Godot, I have a course for beginners where I teach everything you need to know to make games. If that's interesting to you, check the link in the description. Thank you very much for watching, and I will see you in the next one. Welcome back, friends. In this video, we're gonna do some finishing touches to our game. We're gonna create a scrolling background effect along with some particles to make it look cool. And finally, we're gonna create some sound effects. Let's get started. Okay, so the first thing that we're gonna do is making the game more difficult as you play. Because the difficulty curve right now is linear. We're spawning an enemy each second because the enemy spawn timer is set to 1. And chances are, if you're good enough to play the game at that difficulty, you won't lose. And that makes the game pointless to play for a long period of time. We can fix this by making the game more difficult as you play, so that there's actually a point in getting a high score. We're gonna achieve this by decreasing the wait time of the enemy spawn timer each frame. We're gonna set it to be 2 at the beginning of the game so that the beginning stage is relatively easy. And as time goes on, we're gonna decrease it until we reach 0.5 seconds. And we're not gonna go below 0.5 seconds because that would be just too difficult. In fact, it would probably be impossible, but you can experiment with this and see for yourself. We're gonna cap it at 0.5 seconds, like I said. So let's set this back to be 2. And let's get into our script and implement this. Okay, I think we have a reference to the timer, right? We do. Good. Now we just need to, inside of the process function here, we just want to access the wait time of the timer and subtract from it each frame. We're going to subtract delta. Let's rename delta real quick. Times, let's say, 0.005. So because process is run each frame possibly for 60 times per second, we don't want to subtract too big of a number here because that would decrease the wait time really fast and the game would get difficult immediately. So that's why we want to subtract a very small number here, like 0.005. And obviously we need to multiply delta here to make this frame rate independent. We can also print this to see the wait time as it gets less and less. So let's play the game. And as you can see at the start, it was 2. Now it's going down. It's currently at 1.97. And as time goes on, it is going to go down, down, down to 0.5. At that point, we want to stop it from decreasing anymore. To do that, we could use a clamp here like we did with the player's position. I'm just going to do an if statement here. And I'm going to check for wait time. If it is less than 0.5, or let's say it's greater than 0.5, let's decrease it. Otherwise, if it is less, let's set it back to be 0.5. Let's actually make this an else if it is timer.waitTime less than 0.5. Let's set it back to 0.5, and if it is 0.5, we'll just leave it alone. So with this, we should not go below 0.5, and that's good. But to test it, this, 0.05 isn't going to be fast enough, and I don't want to wait for 2 minutes just to test this. So I'm just going to set this to be 0.5, just so we can see the end result real quick. And as you can see, we reached 0.5 and stopped decreasing the timer's wait time. And as you can see, the game is currently way more difficult. And yeah, okay, so this is what we want, but we obviously don't want it to go down that fast. So I'm gonna leave it at 0.005. I think that's a good number, but feel free to experiment here. Okay, so that is the difficulty. Next up, we're gonna create the scrolling background. Currently, the background is empty and it looks horrible, so let's fix that. We're gonna use a parallax background node for this. And the reason is this has a scroll offset that we're going to use to create a scrolling background effect. A parallax background needs a parallax layer. And inside of the parallax layer, as a child of it, we're going to create a sprite. This sprite is going to be the purple stars, which is a texture we have inside of our assets folder here. The purple.png. I'm going to drag this here. As you can see, it is a square. I want this to be not centered. And I'm going to turn on region here. And we're going to set the region to be the window size, which is the width and the height here. I'm going to say 540 by 960. And that's basically going to stretch the sprite to cover the whole screen. But as you can see, currently it is not being repeated. We can fix that by going into the texture settings here and set the repeat to enabled. That way the sprite is repeated and it looks nice. So just this alone would look fine if you play the game. But I want the background to scroll so that, the game feels more alive, I guess. And we can do that with the scroll offset of the parallax background. And we're going to do that from our script. So let's go to the game script here. I'm quickly going to create a reference up here called parallax background. Let's say PB. And like I said, this has a scroll offset. So inside of our process here, let's stop printing the wait time. Inside of our process here, we're going to say pb.scroll offset. And this is a vector 2, if I'm not mistaken. Let's take a look at it. Yep, it is a vector 2. So this has a Y property. We're going to add to this each frame delta times. Let's create a variable called scroll speed. And up here, let's create that variable. Let's set this to be 100. Okay. So this will increase the scroll offset each frame, which is what we want. I also forgot to do something here. Inside of the parallax layer, we need to go to the motion settings here and set up the mirroring. So this will make it so that when the background is scrolling, it mirrors itself so that it looks like an infinite, never-ending texture. If we play the game now without mirroring, you will see that the background is just, going down and there's nothing behind it, nothing coming after it. But if we set up mirroring here, and the way we do that is we're going to say 960 for the Y, and we don't care about the X because the background will move from up to down. And it will never move left and right. So the X mirroring doesn't really matter in this case. But for the Y, we want it to mirror itself at the end of the window here. So let's take a look at it again. And you can see that with the mirroring, it is repeating itself as it scrolls. And this is the final effect that we want. This looks fine. As the last thing, I'm gonna check the scroll offset actually, because currently if we print this, let's print the Y value actually, you'll see that it just keeps on increasing, and that's fine. And if we leave it like this, I don't think we would see any problems, but you might run into some issues if you just let the game running for a long period of time. So let's be responsible and fix that as well. So we know that the screen is 960 pixels, so we can simply say pb scroll offset .y. If it is greater than or equal to 960, we can just reset it. And because we're resetting it at the exact moment it mirrors, this shouldn't be, visible. Let's also print it. So now, when the scroll offset goes above 960, let's wait for it. It should reset and, there's no visible difference. And that's good. And that is the scrolling background effect. Next up, I'm going to create some particle effects to enhance the look of our background. Let's create a GPU particles node here. And we're going to call this stars, star particle effect. I'm going to move it up here. We're going to create a process material here. And I'm going to put this at the center on the x-axis, which is 270. And I'm going to move it up a little. Let's say -50. You can see the particles being emitted there. We're going to set the amount to be like 20. And I want the emission shape to cover the whole x-axis of the game area. So we're going to go into the material here and set the emission shape to be a box. And the extents are going to be 270 on the x, so that we're emitting at the full width of the game screen. Let's set the gravity to be 0, we don't need it. And I'm also going to set the spread to be 0 because we want these particles to go straight down. We don't want them to, have a spread. And the direction is going to be actually -1 on the y because we want these to go down. Okay, let's give these guys some velocity. So the initial velocity, I'm going to say -1000. I want these to go down rather fast. So both of these are going to be -1000. Now we can see them going down. I'm not going to use this default texture for the particles. So down here we have a texture slot. I'm going to use the star.png that I have. And this is going to create this effect basically. Finally, I'm just going to change the lifetime of these to be 1.25. I'm going to pre-process them for like maybe 5 seconds, let's say. And I think that's going to be all for this effect. So now if we play the game, we have this nice, star effect that makes it so that the game just feels faster now. It feels like we're going through space really fast. Okay, good. And we can stop printing the scroll offset here. Okay, so that is the star particle effect. And finally, as the final touch to the game, we're going to create some sound effects. Let's take a look at our audio folder here. So we have an explode, hit, and laser sound. So we're going to have all of these inside of the game scene here. I'm going to create a node called SFX. Let's put this at the top. And inside of here, as a child of this, we're going to create an audio stream player for each of our sounds. So 3 audio stream players here. The first one is going to be the laser sound. The second one is going to be the hit sound. Third one will be the explode sound. So the laser sound is going to be for the player. Let's give it the laser.ogg file. The hit sound is going to be when the laser hits an enemy. And the explode sound is going to be when the player dies. Okay, let's go into our script and create a reference for these sounds. Okay, now we simply need to play these at the right times. So the laser is going to be in the player laser shot function here. So at the end here, we can say laser sound.play. The enemy hit is going to be different because we currently don't have a signal for when the enemy gets hit. So let's do that last. And the explode is going to be for when the player gets killed. So up here, let's say explode sound play. So with these alone, we should have a laser sound. And we should also get a sound when the player dies, and we do. Apologies if that was a bit loud, but okay. So finally, let's go into the enemy script. And in here, we're going to create a new signal called hit. And we're going to emit this inside of take damage. So if the enemy got hit, just emit the hit signal. If the enemy got hit with the laser and if it didn't die, let's just emit the hit signal. And back in the game script, when we spawn an enemy, we're going to connect the signal to a function called onEnemyHit. Let's create this. And in here, we can just play the hit sound. And now when we hit enemies, a sound should play. It didn't. Let's see why. Okay, the problem is obviously I'm not emitting hit when the enemy is killed, so we're only getting it the first time we hit the regular enemy, so my mistake there. So we should also play this when they get killed. We can also emit the hit signal when they get killed as well, but I'm just gonna do it this way. So now when we hit them, we should get the hit sound both when they take damage and when they die. Okay, great. So that is the sound effects. And that is going to be it for this lecture. This is all I wanted to teach in this series. Feel free to take this game and create something of your own. Practice makes perfect, and it is the best way to learn. If you found the video and the series useful, please leave a like, comment, and subscribe. If you want to learn Godot, I have a course where I teach the basics of Godot for beginners. If that's interesting to you, please check the link in the description. Thank you very much for watching, guys. Stay tuned for more videos, and I will see you in the next one.